right, this is lesson 104 of Algebra 2 on page 429. Okay, I want us to talk about the difference between irrational and rational numbers. Okay, what is the difference between an irrational and a rational? Anybody know?
Rational is just like a ratio. I don't know how to say it, like a 4 over 7.
Correct, exactly. It can be written as a ratio. It absolutely can be written as a ratio. And what about irrational?
Was it like imaginary or something?
No. Okay, so this is the real number system. It's made up really of all of those. And then complex is made up of reals and imaginary. All right, so imaginary is on the other side. Irrational cannot be written as a ratio. It cannot be written as a ratio. So it's like pi, square root of 2. All irrational numbers have unending decimal places. All irrational numbers have unending decimal places.
Huh? Sorry, take it.
Got it?
Dude,
You're very
Okay. Listen, every rational number can be written as a ratio. Okay, so it could also be that. That is rational. That is called a terminating decimal. I can write this as a ratio. All right, so it's 0.0123. I can write anything over 1 without changing the value, right? So I could write over 1.0000, then just eliminate the decimals. That's 123 10,000ths. Of course, that's how you'd read the decimal place too, right? All right, so when you have a terminating decimal, all of those can be written as fractions.
Can I try to read your number off?
All of those can be written as terminating as ratios. You got it? All terminating decimals can be written as ratios. The way you do that is it's important to line up your decimal places. Is to write it over 1 and the same number of decimal places, then just eliminate the decimal. It's as though I'm multiplying the top and the bottom by 10,000. And 10,000 over 10,000 is just 1. So I'm not changing the value of it. Make sense? All right, so this is a rational number. This is a rational number. I'm going to erase this, but so is this. Any number with repeat decimal places, Paul, is a rational number. Y'all know what this rational number is. What is it?
0.3 repeating.
Okay, and what is the ratio of that?
1/3.
1/3. Okay, I'm going to show you how you get that. Okay? We're going to write 2 equations. You're always going to have 2 equations. I'm just going to write the number. The number equals 0.3 repeat. I'm going to write a couple of the repeats. Got it? We know it goes on and on and on, right? Now, are you listening? This is where you need to pay attention. How many repeat decimals do we have? 1. Just 1 repeat decimal. So I'm going to take this number and multiply it by 10. Why 10? Because it only has 1 repeat decimal. If there were 2 repeat decimals, I'd multiply by 100.
It won't be a double.
Just a minute. I'm going to show you one. Okay? If I had 2 repeat decimals like 0.67 repeat, I'd multiply by 100 because I have 2 repeat. If I had 3 repeat decimals, I'd multiply by 1,000. 4,
10,000.
10,000. You got it? The number of zeros is dictated by how many repeat decimals?
What's the difference between this and one of the irrational numbers?
The difference is this can be written as a ratio. So we're going to take repeat decimals and write them as ratios. Got it? So here's how you do it. You write the number. Number equals, right? That's what the number equals, right? Now, because I have one repeat, I'm going to take 10 times the number. And when I multiply by 10 on this side, I multiply by 10 on this side. What does it move? The decimal place to here, right? You line your decimal places up, so it becomes 3.333 repeat. Right? Do you see what I did? Now I'm going to subtract the equations. 10n minus 1n is 9n. My decimal place. What happens every place back here when I subtract them?
Cancel out.
They are all 0, right? 3 minus 3, 3 minus 3, 3 minus 3, all cancel out. What's 3 minus 0? All right, now I divide, right, by 9. What does n equal?
1/3.
Okay, that was the easy one. Okay,
I was like,
now, let's go to example 3 on page 430. We'll come back to the first two examples. We're just going to focus on repeat decimals here. All right, so I'm going to write what the number is. The number is 0.016. What is repeated? All right, 2, 3. I'm going to write a couple of them, ... Got it? Now I have 2 repeat decimals, so what am I going to multiply this equation by? 2 repeats, 100. So I'm going to multiply it by 100. What does that move the decimal place?
To the right.
To right here. Does everybody see that? So that's what I'm going to write. 1.6232323 and subtract. Notice what happens from here back.
just 0.
It's just 0. Got it? So 100n minus 1n is
99.
99n. Now I'm going to do just the subtraction. I need to borrow. Got it? 13 minus 6 is 1 minus 1, 6.1.
Divide by 90.
Now, I'm going to divide both sides by 99. I'm going to write 99 in the same number of decimal places. You got it? So that the number is 1607 divided by 99,000. All right, if I put this in your calculator, do 1607 divided by 99,000.
Where's my 749?
It's just 0.016232323.
Right. Right.
So why we
What was the point of that?
The point is to show that you can write this number as a ratio and define what the ratio is.
Cool.
All right. Let's look at 104.4. 104.4. We'll stop at 104.4. All right, what is the number? The number is 1.0031. Now comes my repeats. 5, 4, 3, 5, 4, 3. I'm gonna write a couple of them.
Why would you like 2 repeats
I just write a couple of them because that's what I do. I always write a couple of them because I want to make sure that I have enough out there for the top equation to line up to. All right, now I have 3 repeats. What am I going to multiply this by? 1,000. 3 zeros. 3 repeats, 3 zeros. 1 and 3 zeros. You got it? 3 repeats, 1 and 3 zeros. When I multiply it by 3 zeros, it moves the decimal place 3 to the right. I want to line up my decimal places. This is going to be hard. 1003.1543. 543. Okay, I know I'm going to keep repeating from here on out. Right? Now I'm going to subtract. 1,000 in minus 1 in is 999 in. You're always going to have 9s here. Always. Because it's going to be 10 minus 1, or 100 minus 1, or 1,000 minus 1, or 10,000 minus 1. Right? Yes. All right, hang with me. Now we're going to do subtraction. Guys, here's where I see students making the mistakes. You don't line up. You cannot put this in your calculator because this number keeps repeating on and on. So do it manually. 3 minus 1 is 2. That's 1. That's 5. That's 1. 2001. Now divide both sides by 999. But I'm going to write the same amount of zeros and then eliminate the decimal. And I can simplify that because they're both divisible by 2. You probably can't put that in your calculator, but you could simplify it.
Why couldn't you put it in your calculator?
Well, will it simplify it? Put it in your calculator and see if it'll simplify it. I think it's going to give a decimal to you.
You can also push S to D and it'll give you a fraction.
Okay, let's see. Sometimes it doesn't with these. It's
It doesn't. It just gives you that.
my experience over time is when you have these big numbers, you just have to know that they're both divisible by 2. So divide that by 2. Divide that by 2. Okay, well, let's go back to one more. How can I write this as a rational number? Just one more. Let's do number 1. How can I write that as a ratio?
314 over.
Yeah, right? You're writing it over 1.
Yep.
Same number of decimal places. 314 over 100,000. Got it? Terminating decimals and repeat decimals are rational numbers.